Welcome to StartupHakk. I'm Spencer Thomason, and here at StartupHakk, we love to train software developers and build custom software solutions. I do a lot of work as a fractional CTO, so with over a decade of executive leadership and a solid 25 years of software development, I've mastered the art of transforming technology, teams, and products. So, the large LLMs get all of the big press, and right now there's an ever-evolving landscape of AI. And we've grown accustomed to the idea that bigger is better. Can't say that one tonight. Mega models like GPT-4o and a lot of those have dominated the conversation, like Llama and a lot of these really ultra large models, flexing their muscles with billions and billions of parameters. But what if I told you that the smaller, more agile models are sneaking in to steal the show? We saw some of this last week with the Google 9 Pixel launch event. But new benchmarks are revealing that these leaner models trained for specific use cases are starting to outpace their smarter, lumbering counterparts. So these models aren't just a novelty, they're a game changer. They can run on embedded devices and smartphones, making AI accessible in ways we've only dreamed about. So let's dive into this topic a little bit today. All right, so we're going to dive into this, and I've got about half a dozen reports that we can go through, but I've gone through about 20 different reports, and I've been watching these for a long time because we've actually been playing with small models trained for specific uses for some time. We built AskMini.ai, and if you haven't checked that out, it's a super cool tool that allows you to query question against multiple different LLMs. So you can actually select part of the page, highlight it, and then select it, and it'll actually query multiple LLMs for you. It lets you switch between the chat of which ones. We're doing tons of improvements, but we've really done this as an opportunity, like with everything that I teach, as a way to really dive in, learn about AI, and particularly to be able to work with some of these small language models. So imagine an AI model that you can fit into your pocket, literally. Small language models are now compact enough to run on smartphones without breaking a sweat. So gone are the days where you need to have a server farm just to deploy a chatbot or a smart assistant. These models are designed to be efficient, consuming a fraction of the electricity that their bigger siblings demand. This isn't just about going green, it's all about making AI scalable and sustainable. It's also about security. We saw a lot of this last week with the Google Pixel 9 launch event, where Google is starting to pack Gemini into the phone, right? And so the implications for mobile technology are huge, and the doors are open for new applications, and it's even bigger as developers for us to be able to leverage this, because honestly, not everybody has hundreds of millions of dollars to train the latest models with 400 billion parameters. So it's not just about efficiency, it's about cost. Hosting these small models is a fraction of the expense, which is music to any startup's ears. So think about it, more performance for less money, and that's a developer's dream. And when these models are tailored for specific tasks, they don't just match the performance of larger models, they can actually surpass it on specific tasks. Again, you're not trying to boil the ocean here, on a specific task, right? So they focus on specializing. The focus on specialization allows a smaller model to excel in niche areas where general purpose models might falter. So it's like bringing a laser to a knife fight, precise, efficient, and undeniably effective. And so again, check out AskMini.ai. This is where we started to play with these. But we really love to train software developers. So here at StartupHakk, we also have lots of code samples for free. And a lot of these actually will train you on AI. So let's dive into some of these reports and take a look at some of these. So I thought this was a really interesting one here. What are small language models? And these guys actually break this down. I'm going to put a lot of these links down below. And so, in recent years, the evolution of large language models like GPT or BERT have seen parameter counts soar from hundreds of millions to over 1 trillion, and successors like GPT-4 and now 4o, right? As well as the huge Llama 3.1, right? 405 billion inputs, right? And so the general thing is when you hear about a number of inputs, generally your GPU memory needed to be able to run a model. This is a very back of the napkin number, right? But it is usually 1.2 times GPU RAM for the size of the input. So if you see like an 8 billion parameter model, you need, roughly 11 gigs, give or take, 10 to 11 gigs to be able to run that model. Now, and in today's world, that's small. Um, uh, Facebook's Llama 3.1 actually has over 400 billion inputs, which means you would need somewhere in the range of 500 gigabytes of VPU or GPU RAM, right? So these large graphics processing. I mean, you'd need stacks of H100s, which each run, $50,000 a piece. So that becomes cost prohibitive for any small business to be able to run. So increasingly, answer leans towards precision of small language models tailored for specific business domains, ranging from ID to customer support, right? So you can say, hey, I need it to do this thing. I need to be trained on this data. And it still will have the ability to have human interactions and conversations. That's what the language model gives it. And so really, let's kind of read through some of this. Small language models represent a specialized subset within the broader domain of artificial intelligence, specifically tailored for natural language processing, so it can still talk to you like a human, right? SLMs are characterized by their compact architecture and less computational power. So we've played a lot with a lot of these smaller models, everything at AskMini.ai or stuff that we are running on 8 gigs or less, because we can host it on a server with a GPU that you very well may have in one of the latest gaming machines, right? So one of your later gaming machines is going to have a 12 to 16 gigabyte graphics card. And these are going to range, anywhere from $500 to $1,000, but that's still well within the cost range of most small businesses. Now your H100s are going to run about 50 to 100,000 a piece, and even just one of those still won't be able to run the largest, Facebook Meta Llama, right? So let's kind of look at some of these other ones here. So this is Answer.ai, right? Small but mighty, introducing Answer AI Colbert Small. So this is another example of a very small one, right? And and this was published, this is pretty recent, right here. And so a couple of weeks ago, we released this one, updating the Colbert training recipe to create a state-of-the-art Japanese retrieval model. So again, very specific. This is trained for Japanese, but comparatively, we're introducing a new model, V1, a proof of concept for smaller, faster, and modern Colbert. This new model has just 33 million parameters. This means this could run on even like thousands of documents in milliseconds on a CPU. This doesn't even require graphics, right? And you can see with that tailored approach, you can see how this is, even with 33 million, how they're getting these average scores. Now, this is a very specific trained use case, and that's the whole point of what I'm trying to get to here. I'm not a huge fan of these behemoth of large language models, right? And I think that's what we're starting to see here, is we're starting to see some really good intelligent use case of these. Not only is it greener, but it's cost effective, right? And plus, you don't really care about, if you're trying to answer customer support about sales, right, about selling of your particular product, and you want to be able to answer to that, or have the chatbot or the AI be able to answer to that, you don't really care if it can do complex calculus, right? And so, again, that those large language models, those really large ones like Meta Llama, ChatGPT, they're trying to be able to solve everything, and most people don't really need it to solve everything. So again, talking about real world applications here, small models can be perfect fit for industries where resource constraints are the norm. Whether it's healthcare devices, IoT, or even drones, these models can operate effectively in environments where every watt of power and every megabyte of memory counts. So again, like we were just looking at that specific use case, 33 million parameters would run on any CPU that's any phone built in the last 10 years, right? Any phone can be able to run against 33 million parameters quickly. So in these scenarios, a small model's ability to deliver focused, high-quality output is invaluable. So we're no longer limited by older rules where bigger hardware meant better performance. Now it's all about optimizing the software, the model, the data that's put in, and that's where the small models shine. So another fascinating development is how small models are impacting the AI research community, with models like Microsoft's Phi 3, and we're going to dive into this here in a minute, outperforming large rivals. Researchers are rethinking their approach to AI. Again, if you're trying to harness the human genome, you don't really care if it knows the history of Europe from the 1300s, right? And so like a very specific case, and these models can then become very effective, right? So the old adage, less is more, has never been more true. Smaller models are easier to train, faster to deploy, and more adaptable to changes in the data set or environment. This shift in perspective is driving innovation, forcing us to reconsider what's possible with AI. So it's a paradigm shift where it's bigger, 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 bigger. And now we can say, no, wait, bigger is not always better. And those who adapt quickly will be the ones who lead the next wave of AI advancements. Because what will end up happening is they'll make these really small ones really efficient, which will then allow them to be able to take the ones with a lot larger parameters and be able to specialize them, right? Like, and that's really what I think we need to get to. So security is another area where small models have an edge. Because they require fewer resources, they can be more easily audited and secured. In an age where data breaches are all too common, having a lean, secure model is a significant advantage. Smaller models offer few points of attacks and are easier to monitor for anomalies. This is particularly important in sensitive industries like finance and healthcare, where the stakes are high and the margin for error is razor thin. The future of AI security might be just small, efficient, and highly specialized models. So let's think you're trying to have an AI that's trying to monitor bot trading, right? And you're trying to detect if something in the bot trading is fraud or not, right? And if you're looking at that and you're trying to get that to train that, then you don't really care about it knowing whether, and I'm spitballing here, but every single part of Little House on the Prairie, right? You don't care about those things. If you're trying to detect a network attack and use AI, you're not going to really care about it knowing all the latest Harry Potter, right? So the potential for scaling small models is another exciting aspect. While large models are often cumbersome to scale, small models can be easily replicated and deployed across various platforms. This flexibility is a super big thing for developers and businesses alike, allowing for rapid scaling without prohibitive costs typically associated with large-scale AI deployments. So in essence, a small model democratizes AI, making it accessible to more people and more industries. The scalability is what will drive the next wave of AI adoption across the globe. And I really can't stress this enough. Mark Zuckerberg said that to train Llama 3.1 cost them hundreds of millions of dollars. Okay. So let's just call it $500 million because he said hundreds of millions. I'm going to round up. So let's say it costs $500 million for them to train Llama. Now there's what? 100 companies in the world can even probably roughly afford that, even if they wanted to. And so that just is cost prohibitive. And so that's going to really stifle innovation. If only 50 to 100 companies are the ones who can do that. But if instead we take some of these smaller models and anybody can run them, you can run them out of your garage. Any developer can then run them on a development laptop. You can take these and run them off of your local computing. This becomes something realistic that every business can start to dive into. Now, it mentioned here, and I'm going to hit a couple more of these really quick. So this is really small. So, that's really big. So this is the LaMini-LM. So this is a diverse herd of distilled models from large scale. So these guys actually get into, and this diagram is actually really interesting, right? They seed the instruction off of Wikipedia. They then generate and synthetic instructions plus existing instructions. It generates against here synthetic responses, and then they feed it back in, and this becomes cyclical. These models then get fine-tuned to become what you use. And so these guys did a whole bunch of benchmarking. Let me zoom back out just a little bit here. And these guys did a whole bunch of benchmarking and were able to really find, let me see here, they were able to find that these guys actually performed just as well. So you can see that this LaMini, 7 billion parameters was performing just as well. And so these benchmarks are huge because, again, a 7 billion 7 billion can run pretty, it might be a little tight on an 8 gig graphics card, but you can pretty comfortably find those 8 gig graphics card around for under $200. And a lot of newer gaming laptops are coming with at least 8 gigs of GPU processing. And so it doesn't take a ton of hardware, sub $1,000 worth of hardware, talking about the whole stack of the machine, and you can now locally train and run and a great set of models, right? And this becomes really, really powerful. And so lots of research you can see here going on into this, and I'm not going to go super deep into this. Um, but ultimately, these guys' findings and this model that they're doing here for how they're training it is very specialized. But large language models with instruction fine-tuning demonstrate superior generative capabilities. However, these models are resource intensive, right? And they say resource intensive because they're saying 8 gigs of GPU is still resource intensive, and it is. But to alleviate this issue, we explored distilling knowledge from instruction-tuned LLMs to smaller ones. To this end, we carefully developed a large set of 2.58 million instructions, right? Based on existing and newly generated instructions. So this report was really interesting, and they found that they could actually beat the GPT 3.5. These guys are open source. You can take this and dive into it. And so these guys are another one of these really great guys that are doing really amazing things on the open source platform. Now, it's not just the open source guys that are doing this. Like we mentioned, Google just announced the Pixel 9 launch with Gemini packed into the phone. So they've got the Tensor chip actually running it, and there's some mixed reviews out there on how the Tensor chip on running on it. Looks like it's overheating and downclocking, which is a bummer. I think they'll get it fixed in like version 1.1 of the. Hopefully hopefully they'll get it fixed. Hopefully they'll get it fixed before they really release. But Microsoft Phi 3. So it's not, Microsoft's obviously one of these companies that invested a ton of money into AI, and they've actually thrown a lot of, they actually own a portion of OpenAI. But what's really interesting about this is quality versus size, right? You'll notice this model they're showing here. So like they're testing Phi 3 Mini on 128K inputs. Like that's tiny, right? 4K inputs, right? Phi 3 small and Phi 3 medium. I think their medium is 7 billion inputs, right? And it's benchmarking along with Mixtral, which is an open source for Mistral, right? So Microsoft's here, tiny but mighty. The Phi 3 small language model with big potential. So this is sometimes the best way to solve a complex problem is take a page from the children's books. I don't know where they're going with this story, but LLMs have created exciting new opportunities to be more productive and create using AI, but their size means they can require significant computing resources. I was reading a report today that says there's no way we're going to keep up with the data center needs that we need because of these huge language models. It's just unrealistic, and we can't keep up with it. And this is just, again, I think we've got to really push to try to become more efficient. I just think there's a ton of waste happening here. So Microsoft has, really invested into these large models, and you can see Phi 3 is benchmarking across all of the other small models. I would kind of expect that from Microsoft and a company with the resources of Microsoft, but it's exciting because this is open source too, so you can go pull this down from Hugging Faces or Olama and play with this. Here's a report about the 5 leading small, and I'll drop all these, into the down in the comments, so you should be able to grab them. And as always, make sure you leave a comment because I really appreciate when people say hi. It's like the best compliment I can get is when people are watching my videos and they drop a comment to just say, "Yo, what's up?" I enjoy that. Let me get back to my notes here. And so small models aren't just about doing the same thing as the large models on a small scale. They're about doing things differently. By focusing on specific tasks, these models can outperform generalist models in key areas. Think of them as like a Swiss Army knife of AI, small, versatile, and incredibly useful in the right hands. Now, it's not one of the big fat Swiss Army knives, right? The one, and that's it's actually a decent analogy because if you've ever seen one of those Swiss Army knives that has like 16 million blades and it's like this wide, like I'm not talking about length, it's like this long and like this wide, something you would never actually carry in your pocket, right? Because it's so cumbersome and huge. What you want for a Swiss Army knife is that little tiny one that has like 5 specific things you use all the time and you carry it on your keychain, right? I drive a Tesla, so I haven't carried a keychain in years. But you know what I mean. 5 things that you would actually use. That's a great example of what these small language models are, right? They consume less power, require less cooling, and can be deployed in more energy-efficient ways, even into mobile. And that's where I think we're going to get really huge. This isn't just about good for the planet, it's good for business. Companies that can deliver high-performance AI while keeping energy costs low will have a competitive edge in the market. Now, we love to also train developers on AI. We have a ton of AI videos in our programming courses, and we're going to be producing more. And we have some really exciting announcements coming up. We're working to help to train developers as well as to build custom software solutions for people. And so we work really hard to try to make sure we're staying on the cutting edge of all of the AI needs. So in conclusion, the rise of small AI models represents a huge shift in the AI landscape. These models are proving that you don't need to be big to be powerful. With their ability to run on a wide range of devices, consuming less energy, and be easy to scale, small models are setting new benchmarks that could very well change the game. As developers, we need to be ready to embrace this change, leveraging these models to create innovative, effective solutions. There's one other piece that I want to dive into on this. One of the advantages of running a small model is you can house the model, right? And so a single company on a server with their own systems can house the model, work with it, train it, and that data stays inside their own walls. One of the things that I think we're going to find the repercussions to is all these people who are pumping way too much data out into the cloud with pumping so much data into ChatGPT that's not a black box. That is going to ChatGPT, right? You are pumping that out into the open web, and I've seen some dangerous things happen with companies who think, oh, well, that's private, right? No, it is absolutely not. And so I think security is going to become a huge play in this. So being able to run your own your own language model is going to be paramount as we start to really move forward as people understand the implications here. So the rise of small AI models is setting a new standard in efficiency, scalability, and performance. These models are proving that size isn't everything in this. Specialized focus AI can outperform larger counterparts. So from reducing energy to scale across multiple platforms, small models are paving the way for a more accessible and sustainable future in AI. This shift represents a new chapter in AI, one that could redefine how we approach technology in the years to come. So, what are your thoughts? Do you agree? Do you disagree? If nothing else, just say hi. Say, Spencer, you're crazy. But I love having great conversations, especially around tech. Honestly, one of the best compliments I get is when I start getting comments rattling in, and I answer every single one of those myself. But here at StartupHakk, we love to train software developers in our coding boot camps and to build custom software solutions. So reach out. We'd love to help. Hit the links down below and check out startuphakk.com today. Also, make sure you go back and check out our previous videos because we have tons and hundreds of coding samples, and we're always producing more. And otherwise, we will catch you guys next time. Make sure you like and subscribe to the channel because we bring you lots of great tutorials and tips that every developer should know. See you next time.